Okay guys, this is lesson 2.1 video on linear and quadratic functions and modeling. There's 5 objectives in this lesson. There's going to be 2 videos for this lesson. This first video we're going to focus on determining if a function is a polynomial function. We're going to find the equation of a linear function, find the vertex and axis of symmetry of a quadratic function and apply the quadratic function. And then on the second video, we're going to deal with the correlation coefficient. Transforming the quadratic pairing function, we did that in chapter 1, so I'm not going to spend too much time on that. Let's begin with polynomial functions. Here's the definition. It's going to be a bit confusing, so I'm just going to write a polynomial function. So let's just say write f of x equals, let's say 2x to the fourth plus 3x squared minus x plus 1. This is a polynomial function. Polynomial functions, the terms are written in decreasing order. That is, with the largest exponent first and the next highest next, etc. The first term, when written in decreasing order, is important. It tells you the degree of the whole polynomial. So if I look at this first term here, the degree is going to be 4. So the degree of this polynomial is 4, and then the leading coefficient is 2. The first few homework problems can ask you to identify those two things. Now, it's important to recognize whether a function is a polynomial function. Polynomial functions have variables raised to whole number exponents. In addition, there are no square roots of variables, no fractional powers, and no variables in the denominator of any fraction. Let's look at a couple examples. So which of the following are polynomial functions? For those that are polynomial functions, state the degree and leading coefficient. For those that are not, explain why. Now, in 1 we have g of x equals 13x minus 4x cubed. Let's write this in decreasing order. So g of x equals negative 4x cubed plus 13x. This is a polynomial function, so we're going to say yes. The degree is going to be 3, so it's a degree 3 polynomial, and the leading coefficient is going to be negative 4. Alright, let's erase that so we have more room for the next few. Number 2, we have f of x equals 7x to the negative 5th minus 12. This is not going to be a polynomial function because of the negative 5 as the exponent. Alright, so we can't have negative exponents. Number 3 here, we have h of x equals 10x cubed minus 6x minus 1/2. This is a polynomial. Its degree is again going to be 3, and then the leading coefficient is 10. Number 4, this is not going to be a polynomial because of the square root. Alright, so you can't take the square root of variables. Square root. Alright, and then this should be number 5 down here. Alright, f of x equals 1 over x. This is not going to be a polynomial function because we have x, we have a variable in the denominator. Alright. Now, here's just the chart that we're focusing on this, really this section on linear functions and quadratic functions. So linear functions, we have their degree 1, quadratic functions, degree 2. Here's the form. This should all be familiar. This is standard form for the quadratic here. We have slope-intercept for the linear function here. Now, constant functions, so something like y equals 2. Alright, the degree here is going to be 0. Alright, and then y equals 0, the 0 function, that degree is going to be undefined. Alright, and then this little note here we just went over in the first example. The largest exponent within the polynomial determines the degree of the polynomial. Alright, so linear functions, a little bit of review. The highest power of x is 1. Has the form y equals mx plus b. The graph is a slant line. It's neither horizontal nor vertical. Rate of change and slope are the same thing. And then the initial value, or y-intercept of a linear function, is the constant term. And this is true for any function. Alright, now in example 2 we want to write an equation for the linear function f such that f of negative 1 equals 2 and f of 3 equals negative 2. Now this is just a fancy way of writing an ordered pair. So when I plug in negative 1, I get out 2. So I have the point negative 1, 2. When I plug in 3 for x, I get out negative 2. So I have the ordered pair 3, negative 2 here. From the prerequisites section, we learned how to solve problems like this. The first thing you want to do is calculate the slope. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Alright, and so my y sub 2, it's negative 2, minus my y sub 1, which is 2, over 3 minus negative 1. So negative 4 fourths, or negative 1, is my slope. The next step here is you can do a couple different ways. You can pick a point and take this slope and plug it into point slope form, or we can write down slope intercept form, y equals mx plus b, and then pick a point, plug in the point, plug in the slope, and find b here. So that's what we'll do. So we'll take this point, so negative 1, 2. So 2 is my y, equals negative 1 times my x, which is negative 1, plus b. So 2 equals 1 plus b. So my y-intercept is 1. Alright, and so I have a y-intercept of 1. I have a slope of negative 1. So, I write f of x equaling negative x plus 1. Alright. Now we're going to jump around a little bit here. We're going to go to talk about quadratic functions and their graphs. Here's a little bit of review. The graph of f of x equaling ax squared, where a is greater than 0, is an upward opening parabola. When a is less than 0, the graph opens down. Regardless of the sign of a, the y-axis is a line of symmetry for the graph y equals ax squared. Now in your homework it'll ask you to find the axis. That's just another term for the axis of symmetry. So if you're asked to find the axis of symmetry. The vertex of the parabola is always the minimum or maximum point on the parabola. It intersects the axis of symmetry. Alright, and then there's two ways in which we can write a quadratic function. From Algebra 2, you know that one way is in standard form, and the other way is in vertex form. Alright, now, if we have something written in standard form, alright, usually what you're going to have to do is you're going to be asked to find the vertex. So here are the steps to find the vertex of something written in standard form, or quadratic written in standard form. And then here's how to find the axis of symmetry. Alright, so let's use these steps. In example number 4 here. So it says find the vertex as an axis of symmetry of the function below, then rewrite the equation in vertex form. The first thing that you should notice here is that the terms are not written in decreasing order. So we have to rewrite this. So we're going to say f of x equaling negative 3x squared plus 6x minus 5. Alright, now step 1, we want to find the vertex. So to do that, to find the x-coordinate of the vertex, solve for x equaling negative b over 2a. So x equals negative b over 2a. So x equals negative 6 over 2 times negative 3. So 2 times negative 3 gives me a negative 6. So x equals 1. Now, to find the y-coordinate, we're going to plug x back into the function and solve. So we're finding the y-coordinate of the vertex now. So we're going to write f of 1 equals negative 3 times 1 squared plus 6 times 1 minus 5. So that equals 1 squared is 1, so we have negative 3 plus 6 minus 5. Negative 8 and 6 gives us negative 2. So my vertex is 1, negative 2. Alright. And then it asks, what is the axis of symmetry? Now the axis of symmetry is the vertical line. It's basically the whatever the x-coordinate is, it's that vertical line there. So I'll abbreviate axis of symmetry, and again it's a line, so we're going to say that's x equaling 1. Alright, now it says to rewrite the equation in vertex form. So before we rewrite it in vertex form, let's look a little bit, we'll kind of take a step back and look at vertex form for a minute. So the big thing and why vertex form is nice is because we can immediately identify what the vertex is. The vertex is h, and the ordered pair h, it's hk, and the axis of symmetry is x equaling h. The thing you want to remember about vertex form, so if I have something written in vertex form, let's just say f of x equaling 3 times x plus 5 squared minus 3, and I have f of x equaling 3 times x minus 5 squared minus 3. Alright, so both of these are written in vertex form. Now, if you want to write down what the vertex is always going to be the opposite of what you see here. So, I'm sorry, the x-coordinate of my vertex is always going to be the opposite of what you see here. So, my vertex is going to be negative 5. The x-coordinate of my vertex is going to be negative 5. And then the y-coordinate of the vertex is my k here, which is just negative 3. Now down here, all right, I see a negative 5, so the x-coordinate of my vertex is going to be positive 5. All right, and then my k is, again, just what you see. It's negative 3. So, back to our problem, we have to put this in vertex form. So, I'm going to rewrite, so let's write f of x equaling a times x minus h squared plus k. So, f of x is going to equal, well, my a is right here, that's 6. Oh, no, Mr. Barber, that's not, looking at the wrong one, so you got to be careful here. The, oops, my a is negative 3. So, I'm going to have negative 3 times x. Now, this is going to be minus 1 squared, and then my minus 2. So kind of ran out of room there, but in vertex form it's negative 3 times the quantity x minus 1 squared minus 2. Alright. Okay, example 5. For the sake of time, I completed all the work here, going over and finding what the vertex was and the axis of symmetry. I followed the same steps as I did in the previous example. Alright, so if you want to work through here and work through this example, you want to make sure and check that you get a vertex of negative 2, 1, negative 2, negative 1, and an axis of symmetry of x equaling negative 2. Now, in this type of problem where we have to describe this graph, there's one more thing that we're going to have to do, and that is to find our intercepts, or find our x-intercepts, or find the solutions to this quadratic, so we can sketch a graph. Because we're going to sketch our graph and then check it graphically with our calculator. So, in order to find the solutions, we're going to have to use the quadratic formula. Alright, so I'm going to plug in, so x equals negative b, so that's going to be negative 12 plus or minus the square root of b squared. So I have 144, so 12 squared is 144, minus 4ac, so minus 4 times 3 times 11, so minus 132, divided by our 2a, so 2 times 3 is going to be 6. So x is going to equal negative 12 plus or minus the square root of 12 all over 6. And so now I got to divide each of these terms by 6. So x is going to equal negative 2 plus or minus. Now I can simplify the square root. Actually, I got to simplify the square root of 12 first. I got to say that equals the square root of 4 times the square root of 3. And so that's going to leave me with 2 square root of 3. Alright, and then divide by 6, so 2 square root of 3 divided by 6, that's going to be 1/3. Alright, so I can rewrite this as x is going to equal negative 2 plus or minus the square root of 3 all over 3. Alright, and so what I want to do now is find out what that is as a decimal. So negative 2 plus the square root of 3 Okay, so as decimals, my solutions are x being approximately negative 1.42 and negative 2.58. Alright, now I am going to sketch a graph of this. Alright, so my vertex, if I look back, my vertex was -2, -1. So it was right here. Oops. Alright, my axis of symmetry was the line x equaling -2. Alright, and now my solutions are -2.58. So that's where it crosses the x-axis. So about here, and then -1.42. It's about right there. And then this is a parabola that opens upward. Alright, so that goes over the polynomial functions and then the linear and quadratic functions. The next video is going to focus on the correlation coefficient and some of the modeling.